Hello, this is Brian from Tavarin Games, and I want to do something a little different this time. So I've also been working on a strategy map generator that's like what you would see in Civilization or Humankind or other games where you've got a hex-based grid with the generated landmass. The map can scroll infinitely in any direction. As well, I've got it to the point where I've got units on it, a unit you can place on it, and he can pathfind around past these mountains. They can make it around that. He'll show you the path, and then they'll start walking. We can scroll the map while they're moving, and they just keep on going. Click them again. We've got different features and land types. We can generate, I've got this little UI with different presets. You can manually adjust all of these values, but we can also change the presets. So let's say we have a Pangea with very few mountains, and we get this sort of large single landmass with only a couple of mountains on it. We can generate, say, islands is another preset I've got in, and it completely changes up the map. So doing all that in one tutorial video would be extremely long. So this video will focus on just generating up a grid of hexagon tiles and populating it with a couple of land masses, and making the settings so you can change up the number of land masses and sort of their size and shape. So I've got a new project for that, this strategy tutorial project. And the first thing we're gonna need is a tile to place. So you need your artwork, my beautiful artwork here that I've put so much effort into. I've already got in the game, and you can see I've split it into multiple sprites. So we have sprite mode set to multiple. You go up into the sprite editor under slice, and you do it slice by cell count. In this case, we have 6 columns for different types of land. So we've got like blue for water, green for grasslands, plains, deserts, mountains, snow, stuff we can use in the game. Now, if you're drawing your own hexagon, if you want a perfect hexagon where it's 120-degree corners and perfectly the same edge distances, edge lengths, it needs a ratio of 1 to 1.15. So in this case, 100 pixels by 115. So we've got that. We've drawn it up. So drop whatever you like, and we'll pop it into the scene. So let's drag the ocean tile will be the default. That's what we start with. Let's just put it at position 0, 0, and let's name it hex. Just for a nicer, cleaner name. And we need a way to interact with this. So the first thing we're going to do is add a polygon collider to it, because a box collider is the wrong shape. Now, the automatically generated polygon collider is pretty messy. You can see we have some overlap that would overlap with the other hexagons, other tiles, and that would be bad for gameplay. So under the polygon collider, you go under points, and under elements, we're going to switch that to 6 elements for each corner. And let's start doing the corners. So we're going to start at x0, and we're just going to go to the top. So the top, of course, is the ratio 1.15 divided by 2, so 0.575. And that's going to be our top corner. Around the side is 0.5 because it's 1 wide. And then we need half of that, so 0.285 is half of the 0.575 will give us this corner. We then go around, we do the negative that, 285. And then to the bottom, very easy, 0 again on the x, and then negative 0.575. Around the other side, the x's are already correct, but we have to do negative first. And then we can go to the last one. Oh, not negative, 0.285. And you can see we have a nice collider around the outside of the hexagon that is pretty much perfectly lining it. All right, so we want to tile those. So when you do like a square grid, let's copy that, let's paste one in. You would go to 1, like 1, 1, and then the next ones you'd go up 1, and that would be fine for a square, but for hexagons you can see if we do that, they don't line up right. So how do they line up? Well, the point of this needs to line up with the edge of this, and we know that the edge of this is halfway over, so if we take this and we do x 0.5, you can see it's directly above. And then our y value, you can find this by brute force, just drag it down. But it's basically 100 divided by 115. It's our ratio, which is actually 0.86. See, if we set it to 0.86, the lines do not overlap at all. It is perfectly lined up. So there we go. We know that if we're going to generate a grid, we can't just go 1, 1, 1, 1, 1, 2, 3, 4, and then 1, 2, 3, 4. We need to shift every other row by 0.5 on the x, and we need to multiply every row's y value by 0.86. Okay, but we've got that, and we know how to make the grid. So let's drop the hex down into a resources folder named here. I prefer to use resources folders to prefab folders because you can load directly from a resource folder using a function in Unity, and I just think that's useful. So let's delete that on the map. Now we're going to want to generate a grid of that. So one thing we want to do is we want to make sure that we keep this nice and clean. So we want a parent object that's going to hold all of these hexagons, all of these tiles, and we're just going to name that hexes and set its position to 0. So we have that as a parent object. Now we need a script in order to generate our grid and then land masses, and we're going to call that the map maker. So we just generate a new script. Let's open that up. Give it a second. It'll do its compile stuff. We can reload this. That's fine. Give it a second, and come on. There we go. We have a map maker. So the first thing we need to know is how big's our map. So we're going to do a public vector, vector2, that's going to be our map size. So we're going to just set a default value, and that's going to be, let's go 40 wide by 20 tall. So not too big, a decent sized map. We're also going to need the hexes we can place. So we can just call that, game object, hex. And then we're going to want that parent game object we're going to put it in. Just, again, to keep the inspector nice and clean when we're working on it and keep everything nicely organized. So we have that. Now, we don't need this update function. We're not going to use it. At least not yet, if we do ever. But we're going to want a generate function that's going to generate our land. So we'll just call that generate, and we'll actually call it from the start function. So it'll just pop off right away. So we need to draw out our map. So in generate, we're going to go through our coordinates up to the sizes. So we're just going to use nested for loops. So we're going to go x starting with 0 until it is less than the width, which is map size.x. And then we're going to iterate that by 1 each time. And then we're going to do y. Int y equals 0, less than the height of the map, so map size.y. And we're going to iterate that. Now, if we're doing a square grid, that's it. That's all you need to do. That's our, we instantiate at that position. But we need to have a position and modify it. So let's actually make a vector2 of the position. So new vector, and we're going to use the x value and the y value. Again, if you're doing a square, all you need. But we know from before trying to place the tiles together, we know that we need to multiply that y value by 0.86 to make sure that the hexagons fit together nicely. And of course, the other thing we need to do is we need to shift each other row over by 0.5. So what we can do is we can check the remainder of y divided by 2. And whenever that's equal to 0, that means it's an even row. So, 2 divided by 2, remainder 0. So row 2, we're going to shift over. And the same for every other even row. So we need pos.x, and we need to add 0.5 to it and set that as a float. So we now should have the grid positions correct. So let's actually put a hexagon there. So we use the instantiate function. So we're going to instantiate hex. Now we want the 4-part function. So we're going to have the position is actually the second one. The third argument is rotation. So we're just going to use quaternion.identity. That means don't rotate it, just use the default value. And then we're going to have the parent. So we're going to have the hexes.transform will be our parent, and that'll make sure all the hexes are in the right spot. Okay, so that's it. That will generate us a map grid of these hexagon tiles. So let's go back here. We're going to go to the main camera. We're going to add that map maker. So now that we have it, and you can see we can adjust the map size here in the inspector, which is nice. We can drag the parent object in, and we can go to the resources and drag the hexagon object in, and let's hit play and just see what happens. And look at that. Well, we can't move the camera. We haven't given it any controls, so we'll go to scene view, and we can zoom out and look, and we have a grid of blue ocean tiles. Well, that's pretty boring. We need a way to add land to that. So we need a way for each tile to change its land type. So we need another script. Let's go back to our scripts, and let's create a new one, and we'll call that hex type. So this will be the type of land that the hexagon is. And we can also use this in the future to put other variables, like is there a forest, is there a hill, are there resources, all that fun stuff. Gotta actually open it. So we're gonna open that up. The first thing we're gonna declare, though, is we need the actual pictures of each different land type. So we're gonna public sprites. So sprite, we're going to make that an array, and we're just going to call this the sprites. And we're not going to declare it here. We're going to do that in the inspector. And then we need a public integer of the land type. This way we can actually set it in the inspector if we want, but also we can just look at it. So we know the default type is going to be 0 for the ocean. If we look back at the actual art, 0 here is the ocean, 1's grassland, 2 plains, etc., etc. So we're just going to start with 0 as our default. Now, we're going to leave update and start because we will actually use those in the future. But for now, we're just going to create a new function that's going to let us change the type and then change the corresponding artwork. So we're going to call this swap type. And then we're going to take in an integer. We're just going to call this n for the number type we want. So all we do, we set type is equal to n. And then we want, we have to make this a void. There we go. And then we want to set the sprites. So we have to get the sprite renderer from the object. So sprite renderer, and then we can change the sprite is equal to sprites n. And that will change the type and the sprite. And this is public, so we can trigger it from our map maker script. So let's save that, go back over here, let it compile. So we can grab the hex, we can add the hex type script to it. And so the sprites, it defaults as 0, let's set that to 6. And again, as you add more tile types, you can just expand this out and put the different pictures in. And you can change up their order, do whatever you want. This is just what I've done to get a feel for it. But there we go. We have all the different hexagons here and the different types. So we should be able to swap to those types and actually see it in action. So let's actually write this into the script. All right, so we have the map maker. We're going to go down here and we're going to just randomly change some of the tiles. So we need to know how many land masses do we want to make. Again, we're going to make this a public integer so we can see what it looks like. So let's try to generate 15 different little land masses. So we need to basically, we need to go through and make that many. Now, for some, we're going to use a while loop to do that. And we're just going to basically, when we manage to generate one, subtract it from the while loop and until we reach 0. So we're going to first start with a temporary object that matches the masses, because we don't want to erase this master number. We want to be able to work with that elsewise. So we're just going to make a copy, basically. Now, one other nice thing to get in the habit of when we're going to work with while loops is to also have a way to force it to stop. So we can set a number of attempts, and set a maximum number of attempts in a while loop. So that way it will eventually stop. So we want to do, so mass temp is greater than 0. So long as we have masses to place, actually this should be greater than equal to, greater than 0. And then we want to also make sure we don't go over a maximum number of attempts. So we're going to say masses times 2. And now you can see why we want masses separate, because we're using it for other things. Okay, so the first thing in a while loop is to actually, typing a little bad there, set the attempts to add 1, so that way we can track the number of times we've attempted it, and eventually the loop will be forced to stop. Even if something goes wrong and you write in a way that it can go infinite, this will keep it from doing that. Okay, so what we want to do is actually generate a landmass. So we need to go here, and we need to generate a position. So let's go, did I hit caps lock? No. Vector to position. And we want this to be random. In the future, you can put constraints on to determine where the masses can generate. For now, though, we're just going to go completely random within the grid. So we're going to set new vector 2, and we are going to set it. We're going to round off the value because right now we need it as an integer, and we want a random value. So random.value will give you a random integer or a random float between 0 and 1. We can multiply that by the width of the map. So map size.x is our width, and then we can subtract 1 from that, because in here we generate from 0 to map size .x, or less than map size.x. So we need to subtract 1 if we want to stay within the bounds, and we'll do the same for the y. So round it off, so random.value, and then we want to times that by map size.y and subtract 1. So we now have a random position. Of course, as we know from before, our grid isn't a perfect square grid, so we need to make some adjustments. So the first adjustment is let's correct the x value. While we have a y value that is still an actual integer, we can then say the pos.y, its remainder 2 will shift over the x. And now, at this point, we can actually multiply this by our 0.86, so the y is the correct position. We have to do that after we do the x adjustment because we need the y to be an integer. Oh, and we got to make that a float, and there we go. So we have a position. Okay, so how do we actually change the mass at the position? Well, firstly, we need to get the game object, so the actual hexagon that's there. So we can use arraycast to do that. So we're going to do arraycast hit 2D because this is a 2D game at the moment. If you're in 3D, you would just make this a 3D raycast, and you just have to specify the z coordinates. But yeah, let us raycast. So we need its physics 2D, type raycast dot raycast. We don't need to raycast all. We can just do a single raycast because there should only be one object in each location. And even if there's more, it should be the top object. So we need to go at this position. So we're going to raycast at the position. For the direction, I just put the position again because then I make the distance 0. And we also want to only look at the default layer because in the future, if we add in UI elements, we don't want those getting hit. So we're going to use a layer mask. We're just going to get a mask and we're going to set that to default. So our tiles are on the default layer. If you make a different layer, put them on a tiles layer, a land layer, whatever you want to call it, just change that. So we have a raycast. We can then see if we hit something. Now we should, because we have generate up a grid and we're within that, we should absolutely hit something. But in case we don't, we can. This will make sure we don't end up with an error. Now we know the only thing we should hit is a hexagon with the hex type script right here. So let's grab that script and let's actually set it to let's just call it new hex for the hexagon we've just hit, and then we're going to set that to the game object attached to the collider we hit, and we're also going to get the hex type component because we don't care about the game object itself, we want the script. So this is what we're going to work with. Now, we made that function over here where we can swap the type. So let's just access that. So new hex.swap type. And we're going to use 2. So 2 is the second the layer planes tile. Now this should set the hex type to 2 and change the sprite. Well, let's see what that does. Oh, the other thing, before I forget, is we need to tell it we have in fact managed to make mass, so mass temp minus equals 1 when we've done this. The other thing we can do to make sure we actually only generate where we haven't generated a map for, so if new hex.type does not or is equal to 0, so that'll tell us that it's an ocean, and we can make that over. Actually, I just completely forgot I wanted to do this. So we will drag this in. We will only tell it it's made of landmass if it successfully does. There we go. So now we can also be sure we're only modifying the ocean tiles that have not yet been turned into a piece of land. Okay, so let's jump back over here. Let's press play. See what it does. Okay, so let's look at the scene view and you see, look at that. We have a few landmasses. We should have 15. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got our 15 landmasses. So we've correctly swapped them over. Now, one thing we can do right now to make our lives a little bit easier in the future so we don't have to keep stopping and starting this, go to the UI, we're going to add in a button. Okay, we're going to canvas. We're going to set this to camera screen space, and we're going to drag in the camera. Boom, so the button is now the correct size. So it looks good. So that button, we're going to call it the generate button. Do that, and then we want to change the text of that. Generate. So this button, when we press that, we want it to basically generate. So let's go over to here in our map maker. We're going to need to use the Unity Engine UI. So that way we can actually work with buttons. And then we can do a public button. And we'll just call it gen for generates. And then we need to tell it when gen is clicked. So gen.onClicked, we're going to add a listener. And we're going to tell it to generate. We don't need to delegate or anything because generate doesn't take any arguments. Now, since we're doing that, we also want to do something on the generate. We want to erase the previous map because now that we're not just doing it at the start, we can do it whenever. We need to be able to erase it. So we can do a quick for each loop. So this is, we're going to do transform child in hexes.transform. So this will kill all the children. We're going to destroy child.gameObject. So that should compile correctly. So that will destroy everything that's in the game, the hexes, and make sure we don't overlap. So let's hit play again. So we have a land map here. Oh, we have a null reference because we forgot to set the button. That is my fault. Stop this. Hello, stop. There we go. Let's go to the camera and actually put the button in place. There we go. Save it. Run it. Okay, there. No complaints. So we can hit generate and you can see our land masses. We'll go to the scene. They're moving around. So they look like that. Generate. We'll sort out the camera in a future tutorial. So we can move the land masses around. Great. But now this is kind of pretty boring. We just have single dots. Now if we were to go over here and just generate like 300 and go back to the game and hit generate. So we have some land masses, but it's kind of chaotic. There's no real organization to it. So we don't really want that. It's a bit too random. We want to have a little bit more control. So what we can do is with each of these land masses we generate, we can have it start to propagate land outwards, and we can use a couple variables to do that. So we have sort of two variables we can look at. So we have a tile, and we have the 6 surrounding tiles. So we can spread to a number of those tiles. So let's say we wanted to convert 4 of the surrounding tiles to land, and then leave the others free, and make that random. So it'll be the pattern around each tile will be random. And we can also make it so that sometimes it'll generate 3, sometimes 4, rarely, but sometimes 2, but up to a maximum of 4. And then the other option is how far it's going to grow. So the tile it converts, it can tell it to also try to convert some tiles around it and grow. And the next one can do the same, and the next one can do the same for as long as you specify. So we're going to set those two variables. So that way, if you basically take a tile and tell it to convert all the tiles around it, you're going to end up with something that is very samey. Everything will just be hexagon shaped. If you tell it to only do one around it, it's going to be pretty random, like one random, and then it'll convert, and it'll be kind of more linear chains for as long as you specify the growth to go for. So we can set those and make it a little bit random, which we like. So let's go back into our map maker. So here we're going to want those values. So we're going to set them public. Now for the growth value, we want that to be a little bit random. So actually I'm going to make that a vector 2. We're going to call it lowercase grow is equal to new vector 2. And we're going to say, let's say 4 to 7. So that would be kind of smaller land masses. But we want a random value between that to randomize the growth so that not every island is the same size. And then we want the what I call the frequency or freak variable. That's the tiles around it that are going to convert. Let's set that to 3. So it's going to attempt to convert 3 of the surrounding tiles, and then it will propagate its growth between 4 and 7 times. So we have those variables. So we need to go to our hexes, and we need those variables here as well. And we're going to make them public, but the growth will be an integer. We're just going to set a random growth for the first one, but then after that, it's just going to be, or when it gets to the tile, it's an integer. We're just going to give them default values of 1. It doesn't really matter because we're going to be changing it before we do anything. Now, one other thing we also need is we need the map width as a value as well, as an integer. And then we'll just put in the default value of 40 here, but we're making that public so we can change it if we need to. So we need another function. So we need it to be public because we're going to use the map maker to start the first one. So we're going to have our grow function, capital G. All right. Now, when we convert, we need to basically, so nothing's going to trigger yet. I think we compile fine. We need to basically find the coordinates of all the tiles surrounding a piece of land. Okay, so let's go back to our script here, and let's grab those coordinates. So we need a new list. We're going to use a list of vector 2s. So this is going to be just called coords. New list vector 2. Okay, so we have our list. So horizontally, those ones are easy. So we can just add the coordinates. So horizontally, so we want a new vector. And that's going to be, so transform.position.x. So our x position, and then +1 horizontally. And we know horizontally the y position is going to be the same. Oh my goodness. I accidentally deleted that. That is my bad. I don't know what I clicked there by accident. So again, we need new vector 2. Not capital transform. Apologies for that. Transform.position.x +1, and then transform.position.y is going to be the same because horizontally we're on the same y value. So that's to the right. Let's add in the one to the left. So we're going to subtract 1. Okay, so above it. So we're going to do the ones above. But if we're looking above it, we know that it's not +1, or it's 0 or +1, because we know directly it's not directly above it. It's over by a half a tile. We remember that from the grid. And we know that it's not exactly 1 up on the y value. It is 0.86 up, because the ratio for the y values is 0.86. And then 0.5f. So we'll add in the 86. So this is above to the left and above to the right. So we can just copy these and we can get the coordinates below. And all we need to do is subtract the y value instead, and those are below to the left and below to the right. So those are our 6 coordinates. So we have our frequency. We're going to basically loop through with an n value starting at 0 to less than the frequency. Frequency and then n++. So this will attempt to convert one of the tiles around it 3 times. Then what we're going to do is we're going to randomly select one of the coordinates to attempt. So we need another integer. We're just going to call this one m. It doesn't really matter. You can call it index, call it what you want. Dot value times 5 would give us a random value between 0 and 6. And we need to, I forgot to add this, round this to an integer. So this will give us an integer value between 0 and 5, which will allow us to select one of these 6 coordinates. So we need to do a little bit of stuff. If we have a coordinate that goes below the end of the below 0, so the edge of the map, if we look at the scene, we have this 0, and this 0.5. If we're subtracting from this tile, this -1, there's nothing there. Now, you can either ignore that coordinate, or if you want to make it so that the map wraps around, we instead want to get the map width and add that on. That's why we specified the map width as a variable here. So in order for us to actually do the map wrapping, we first have to check, has the x value gone below 0? Is it off the map? So we'll just use an if statement. We'll check the coordinate we're interested in and see if its x value is less than 0. And if it is, we need to add the map width to it. Now, we can't just directly add to the x value of the coordinates when it's in a list like this. So what we have to do is we have to specify a new vector. I tried to do it without specifying a new vector. It won't work, so we're just doing it this way. So we have our new vector 2, and we're going to take the m coordinates x value, the coordinates at m's x value, and we're going to add the width to it. And then it's just going to have the same y value. Dot y. I'm typing so badly. Okay, so we have that. Let us set that in as the coordinate at value m. So we have it wrapping. If it goes below 0, the left side of the map, it'll wrap over to the right. Well, we need to also flip it. So we go else if coordinates m.x is greater than or equal to the map width. Because on the edge, since again, we're going from basically if the map width's 40, we're going 0 to 39. When it gets to 40, we need it to wrap back to 0. So we're going to subtract that. And then this should trigger out, and it should set the coordinates to the other side so it can properly wrap around and propagate. Now, we need to see what or if we have an unchanged map tile there. Well, we already have the code from before, so let's copy that. And we can bring this over. So we check at that position is now going to be the coordinate we're interested in. So coords M. So we're interested in that position. We don't need the mass temp anymore. So we're going to swap that. Okay, so this is going to be our basic growth function. It's not going to propagate out. It's just going to grow into a couple of the surrounding tiles. But let us actually set the variables for it. And we're also going to set the variables for propagation as well right now, even though we're not going to use them quite yet. Okay, so we need this first. Let's set the grow value. So we want a value between 4 and 7, or whatever we set here, between the low value and the high value. So the way we do that, so firstly, we need to do our regular old rounding to integers. And we're going to take the low value, so that's grow.x, and then we're going to add onto it random value that's between the difference between the two numbers. So we need grow.y minus grow.x. So what this will do is we're going to get a value. We're going to get a value that's 4 plus, in this case, like 7 minus 4 is 3. So this is going to be between 0 and 3. So 4 plus something between 0 and 3. So we're going to get a value between 4 and 7. So that'll randomize the size of the islands a little bit, which would be good. Now we want to set the frequency is equal to the frequency. We're not going to change that. And we also want to set the width of the map. We need it to know, because if we change the width of the map in this function, the other one needs to know it. Right. In this case, it's map size.x. Okay. And now we can go to, oh yes, we need to also cast this as an integer, just to make sure it doesn't complain. Okay, so now we can run the grow function. Okay, so this is just going to try one growth over here. So let's pop into here again and let it compile. Press play, and let's go to the scene, and look at that. We have a few islands that have grown just a couple times. So each one has grown 2 or 3, because we specified up to 3, but it might hit, with the random value, it might hit the same one twice, and it won't try to grow into that. But there we go. We have a bunch of little tiny islands. So now let's do the growth propagation. We already have the variable set from the map maker here. So we need to actually code that in. So we want this function to call back into the next tiles. So we're going to want to set the grow values for the tile we just converted. So we set new hex.grow, and it's going to equal the grow value of this one minus 1. So that way, the next tile will grow a little bit less. Now we also will set the frequency, .frequency equals, this one will just stay the same. Okay, the new hex will also need the width that we have. Okay, so it's basically the same as over here. We're just changing up the way the growth works. And then we can tell the new hex to grow. Now, of course, we only want to do this if our growth is actually above 0. So let's also add in an if statement. Is greater than 0. We can then encapsulate all this, so that way it will stop once grow minus 1 is equal to 0, and it won't try to continue past that. Okay, let's go here, and let's load that up. Alright, so there we go. We actually have generated some random land masses. Now, those land masses, maybe they're a little big for this map size, so we can go here. Let's try a bigger map, so 80 by 40. Let's make it pretty big. And then we can go back to the game, generate. And, oh yeah, so we can see the masses are a bit smaller and more spread out there. So let's say we made these a little bigger, 10 to 15 maybe. Not sure what that's going to do. Go back to scene, and oh yeah, look at that. So we've got some nice big land masses. They've grown over the edge of the map properly. So this guy propagated over to this side. Now they don't wrap up to down because I'm considering this more of a left-right strategy-based map. So units will be able to go left to right, but they won't be able to go top to bottom. But there we go. We have our random land masses. If we generate, we can change that up. We can generate fewer land masses, and it won't generate it, and it'll just generate a few. So 5 in this case. 2 of them must have grown together. and we can change the map size and everything. So we've got our options, and this is our basis to work with. So in the next tutorial, I hope to cover making the camera movement work and make it so that it can zoom in and out. If we look at my more complete version, we can zoom in, and we'll zoom into the mouse pointer wherever it is, zoom in and out. We can move the map, use the mouse button. We can use the arrow keys, AWSD, whatever. So we're going to get that, as well as the wrapping of the tiles I hope to include in that tutorial, so that as the camera moves, the tiles will reposition so that they always stay in view and the map correctly wraps. So that's my tutorial for today. I hope you enjoyed it and learned something. If there's something that you saw me do wrong or something I can do better, please let me know. I'm doing this as a learning method for myself as well. Have a good one.